the ATMA College of Engineering, Mysuru. In this video, I'm going to explain you the experiment number 4, demonstrate the use of external interrupt to toggle LED on and off. Okay, so here external interrupt concept is used in order to show the status through LED. Okay, so LED chosen is LED 10. So here we need to find out the pin number required for external interrupt, how it works inside the circuit, and how the pin is mapped to LED 10 in order to make the LED turn on and off upon occurrence of external interrupt will be explained. Okay, so first thing is we need to find out the pin numbers as we done in the previous examples. Okay, so EINT are the external switch 2, which is the responsible external switch we are going to use for external interrupt. Okay, so EINT is the pin name. So you can observe that 7th pin in the CNB1, which is going to be responsible for external interrupt. Okay, so then 7th pin in CNB, that is P2.12, is nothing but second port. 12th pin is responsible for occurring the external interrupt. Okay, and also so here the LED10 is used in order to show the status of occurrence of interrupt. So PWM is the pin that is going to be control the LED10 illumination. So PWM pin number is 1 in the CNB1, so it is P1.23 something, but first port 23rd pin, which is responsible for LED10 to show the status. Okay, so now the found pins are P2.12 is for external interrupt and P1.23 is for LED10 or LED10. Okay, so now I'll explain you like LPC 1768 will accept 4 different external interrupts, namely EINT0 to EINT3. Okay, so what actually meant by interrupt? So if any interrupt among these occurs, then LPC 1768, if it is in the normal execution, normal application, it will going to be redirected to the ISR, that's nothing but interrupt service routine. Okay, so by the vector table, and it will going to serve the ISR first, and then it will going to revert back to or return to normal application. Okay, so here the main important point is LPC 1768 will accept 4 external interrupts. Okay, so now the common algorithm, so in order to get through the status of LED10 upon occurrence of LED external interrupt is, first step is to initialize the external interrupt and LED pins as GPIO. I'll show you the pin number for 2.12 for external interrupt in order to make it as GPIO. Okay, so that is anyhow it's optional step, because the primary function that external interrupt pin should perform is external interrupt itself. Okay, no need to make it as a GPIO. Anyhow, there's a program flow. You can just check the status of all the pins by making them as a GPIO. Later you can move to the particular function you need. Okay, so now what I will do is P2.12, so then responsible pin select register is function select register is pin cell 4, since it belongs to port 2. Okay, then both are moved with 00, so then it will become GPIO. Similarly, you select pin select register for LED pin, that is P1.23. okay, you change the bits of corresponding in the pin select register into 00, then it works as a GPIO. Okay, so now what I will do, I will move that 01 in place of 00. I will going to move 01 into the pin select register number 4 to corresponding bits of P2.12. then it works as external interrupt 2. Okay, external interrupt, or it is generally external interrupt. Okay, so now set the LED pin as output and set it initially. So upon occurrence of interrupt, let the LED is going to be turned off. So for that reason, let the LED pin is set as output and then keep set at the initial stage. Then load int register. It's a 32-bit register with the value called as 70 followed by 4. Okay, 70 followed by 4. So if you disassemble, if you segment the code of 4, then 0 1 0 0, okay, 0 1 0 0, last nibble is, so bit number 2 is going to be 1. Okay, I'll explain why. So I'll go back to my data sheet of the register. Okay, so I'll go to the, this is what the flow of external interrupt register. Here 32 bit, among 32 bit register, from bit number 4 to 31 is reserved. Okay, user software should not write ones to the reserved bits. Okay, now you can observe here, so EINT2 is the external interrupt switch is taken, so only that particular bit should be 1, then 0 1 0 0, then its nibble value is 4. That's why the 4 is loaded here, 4 is loaded in the external interrupt register. Okay, so now again the last step is we need to check the internal flag that is associated with the external interrupt 2, okay, to make the LED toggle. Okay, so I'll show you how to toggle in the program. Okay, so now I'll call the functions of our definitions of LPC17xx.h as a header file, then void EINT2 external interrupt 2 IRQ handler is nothing but interrupt request queue handler. Okay, so function is declared. Unsigned character into 2 flag is associated flag of EINT2. Okay, so then I'll start with the main program or body of the program, int main. Unsigned int character flag equals to 0. System init, it is to update the clock and PLL features. We need to call the core function of it by the CMSys is nothing but a system initialization, then system core clock update for respective update of clock features. Okay, then as we done previously, okay, so LPC pin control pin select 4 is made as GPIO for general purpose. Okay, for just to check the pins we have made as a GPIO 0. Anyhow, this step is optional. Okay, anyhow my pin or my switch is want to work as a EINT2, then you need to move with 0 1 as I show in this previous slide. Okay, so LPC pin control pin select function select, okay, by moving 0 1 to the particular bits of corresponding to the P2.12, then it works as a EINT2. Okay, then LPC pin con pin select 3 ampersand with, so here I made the LED pin that is P1.23 as 0 0. Okay, now to work as a GPIO, then I'll going to set that pin as output, and then I'll going to set as high at the initial stage. Okay, then whatever I said, so LPC serial control of that register, that is 32-bit register called as external interrupt. If you move 4 to it, then it will going to write the 1, okay, in order to clear the interrupt, and again it will going to set for any other interrupt that occurs in the EINT2 pin. Okay, so then if you load with a 4 here, so then the EINT2 will always wait for the interrupt. Okay, then NVIC enable IRQ EINT IRQN. So it's a IRQ number. It's going to be updated through core Cortex M3 microcontroller header file. Okay, so NVIC stands for nested vector interrupt control. So here the flexibility which the LPC1768 has is it can have many interrupts in a nested manner. Okay, it can enable any number of interrupts. So by assigning the number to it, it will go into call the enabling the IRQ, okay, or interrupt request queue. Okay, so for this EINT2, it will going to be enable assign some number that will going to be called by the core function. Okay, then I'll start with the logic part of it now. So obviously it will going to wait till interrupt occurs, then keep the into flag initially set as 0. Okay, so until it is going to be changed, until the flag is going to be set. Okay, so it never come inside. Okay, then if suppose if flag is, if this is an extra flag which is taken to toggle the LED. Okay, so here if flag is 0 0, then LPC GPIO 1 FIO clear. So now we thought, so since we have kept the LED as on in the initial stage. Suppose if flag is 00, then it nothing but interrupt is occurred. Okay, then it is going to clear the LED, then flag is going to be resetted. Okay, else LPC GPIO1 FIO set. So otherwise the initial whatever the status of LED we have placed or we have put, so the same status will be continued by making flag value remains unchanged. Okay, so this is what the status of the way of controlling the LED 10 now to show the status of external interrupt occurrence. Okay, so here the another function you have is void EANT2 IRQ handler. What actually it will do, every time it will going to set the into flag associated with the external interrupt, and then it will going to write 1 to the EANT2 is nothing but always it will going to clears the interrupt, and always it is going to be set for any other interrupt it will going to occur. Okay, so now I'll show you the demonstration video. Okay, thank you. I hope you understood the program flow of external interrupt. So now I'll show you how to download the program into Xfile into hardware and how to execute that. Let us look at the demonstration. So as we have done in previous example, so first command you need to type in order to get the hardware information, that is dmessage. So you can observe that. So UART is connected to TTY USB 0. This is a device ID which is generated by the system. Now you need to call the X file by the command called as LPC21ISP -control followed by path name and /device and device ID, baud rate and clock frequency of the hardware you're going to use. So this is the general command for all the program. You need to change just a X file complete path in order to download the program or X file into hardware. So now I'll say enter. Once you enter, you need to wait until it launches the code into hardware. So now you can observe here, now launching the brand new code. So now if you reset your hardware, then it works. Okay, so now let us look at the hardware. So before resetting, make sure that the connection has been done. So first one is communication cable, okay, and then the power cable. As I said, it's a switch 21. It should be in the on condition in order to download the code into hardware. Now you can observe this connection, that is FRC, which is connected from CNB to CNB1, since external interrupt belongs to port 2, so which is connected to in turn to the CNB connector B. For that reason, this FRC is connected to CNB1 to CNB. Okay, now you can observe here switch 2 is the external interrupt. We have a LD10 which is configured to toggle here. So now I will reset the hardware. So now you can observe here at the initial stage in the program itself we have made LED is turned on. Now I'll call the interrupt by switch 2. If I call the interrupt, now the LED status is going to be off. If you call the switch external interrupt, now again the LED is going to be turned on. This is called as toggling the LED by using the concept of external interrupt. Thank you.